Our big idea is to explore the deeper properties of music and how they've changed over time. Specifically, we want to look at features such as the popularity of music by genre and by year, and how characteristics like danceability relate to that popularity. We're also interested in broader musical trends, for example, how key and key confidence shift through different decades. In addition, we'll track the average tempo of songs over the years and see how it correlates with genres that were popular at the time. Altogether, this will help us answer questions such as, are throwback genres making a comeback, or are we seeing entirely new sounds rise in popularity? The album covers here from artists like Cyndi Lauper, the Notorious B.I.G., Pink Floyd, and the Beatles represent the range of eras and styles we want to study to uncover these musical patterns. Music connects people across generations, so understanding its trends can be really meaningful. Each of us listens to music every day, and we were curious about the hidden patterns behind the songs we enjoy. To study this, we'll use open source data from Acoustic Brains and combine it with Spotify's API. By merging multiple data sources like Spotify, Music Brains, and Acoustic Brains, we'll be able to build a richer dataset and see how different musical qualities interact. Our hypotheses are that Afrobeats is currently resurfacing in global charts, and that so-called recession pop or throwback pop is on the rise again. While rap music might be facing a slower period as more artists are postponing or canceling tours. Through this analysis, we hope to review how listener tastes evolve and what genres are shaping the current soundscape.
Let's talk about what we've done so far. For this part of our project, we worked on converting one of the files from the million song dataset into a more usable format for our analysis. Each file in that dataset is stored in what's called an H5 file, which is a type of hierarchical data format. And basically, it's very efficient for storing large amounts of structured information, is what we've learned, but it's not easy to read or analyze directly. At least not without writing code first. So we built a Python script that reads an individual H5 file and uh, converts it into a CSV file, which we can easily open with Pandas or Excel. The code uses two main libraries. One is the H5PY and then the Pandas library. Um, so basically, H5PY lets us access all the nested groups and attributes inside the H5 file, while Pandas lets us organize the data into a clean table-like structure that we can later use for data exploration and machine learning. Um, when we open an H5 file from the million song data set, we find that it's divided into several groups. There's just so many folders. The metadata group contains basic song information, right? So that's where we get the artist name. That's where we're getting the track title, the song ID, and the release year. And then when we go to our analysis group, it holds numerical audio features. That's where we've got like tempo, loudness, duration, and time signature. These are the things that describe the physical characteristics of our song that we're hoping to analyze. We're also using Music Brains because once you get the Spotify, so you've got a song title, right? That gets converted into a Spotify token or key, right? A specific unique identifier. And what we do is that we work with the Music Brains that takes that token that's specifier in Spotify, converts it into a Music Brains ID. That's what's listed here on the right here. So we're going from Bohemian Rhapsody, right? That's a song. It goes to a token. That token goes to a long ID, and then we ping Acoustic Brains, and that's where we get the features about that's where we get the metadata about the song that's down here. That's what we're receiving. So we've started working on our ETL pipeline. And then going over so we're storing stuff in a Python dictionary, converting into a pandas data frame, um, and then what we're doing is we're using JSON normalized to flatten nested JSON structures. So we're doing beginning intro like exploratory data analysis and feature selection. Clearly, we want to remove some features and that we won't need. We really want right now, we want to focus on beats per minute, key, and danceability. And then kind of combining nice CSV from these three different APIs. And then right now we're looking at some interesting things to do for machine learning. We haven't decided yet, as they might be very complex or not doable with our data. So um, some of the things that we're potentially looking at is doing natural language processing for on the lyrics to figure out sentiment. So here on the right here, our image shows Spotify our Spotify access keys and API. Don't worry, the secret key is not there. But then also this is our output from our code generally from our basic pipeline. We're uh, I've already just gone over it, and then so yeah, this is kind of the characteristics of our very simple pipeline we've worked on. Step one is we authenticate with Spotify API using OAuth. Our tokens returned. We've got a function we've created called get Spotify access token. And then it takes that's where we get the ISRC from Spotify, which is a token, which is the ID. And then we take that ID and then we ping Music Brains. Then we get the MBID from Music Brains. We use that MBID to get specific characteristics about audio analysis from Acoustic Brains. That's where we've got written a function called get Acoustic Brains when we're passing in this MBID as params. And that's where we're getting detailed audio features. And then what we're doing is we've created a function to format to clean up, and that's what we're doing JSONify and JSONify and normalize. So our function is format readable summary. Yeah, and then we're just printing in a clean format. This is an example on the right, what our CSV is starting to look like. Yep. Thank you very much.
For the data slide, we discovered that Spotify's audio feature endpoint has been depreciated for new applications. And upon researching this, we figured out it was depreciated around November of last year. So we were kind of basing our original presentation off this, so we had to adjust a few things. To solve this, we engineered a multi-step data pipeline that has 3 steps. So step 1 is we start by getting a list of the top songs from Billboard for each year using the Billboard Top 100 list. Then for each song, we use the Spotify API to retrieve its popularity score, artist genres, and most importantly, the universal identifier, which is what we need to query the Music Brains database in step 2, which is a universal music encyclopedia that stopped getting new information in 2022, but for our purposes, it is valid for this project. And we're going to use the Music Brains database to find the official Music Brains ID, which we can then use to retrieve a detailed audio analysis from the Acoustic Brains API, which provides things like the tempo, danceability, and musical key data needed for our project. And to answer question 2 for challenges that we've encountered need advice on, we encountered the issue of the Spotify API not being able to give us the original information we needed. So I guess our question would be, do you think it'd be better to roll back the scope of the project or introduce something like this, like a multi-step pipeline in order to get to our original goal?
Our plan is to look at the music charts from years 2016 to 2022 to see which songs peaked in popularity. We would then pipeline that data to other APIs that will give us acoustic properties of the given songs, which would in turn create another data set. Having that new data set, we would organize the data such that we would see the trends in the given properties we extracted. This would show us how some factors possibly correlate to the song's popularity. In order to find this correlation, we would perform static analysis, preferably through graphs, but we still are open to create an interactive system. A goal refinement question that we would have would be whether there will be significant patterns related to the popularity as opposed to genre. There is a possibility that all songs in the same genre they would share acoustic properties, which could fall under the definition of a genre. Although that's the possibility, we believe that the scope of the project is still appropriate for the class because we have a clear idea of what we would love to explore, and we will use the tools we learned in class to perform the necessary analysis in order to obtain our target results.
Workload for this project, we've kind of created 5 different roles for each of us to work on. So the first one was to find the data sources for this project, which we kind of all worked on together, and we decided to use the Spotify API in order to analyze trends over time. And then after that, the next step is data cleaning, and then also working on some preliminary exploratory data analysis and figuring out how to store the data. After that is working on statistical analysis and analyze particular traits in the data set, kind of figure out what trends we can see from there. And then from our findings from that, we can create visualizations for those trends in the data. And lastly, working on machine learning applications based on all of our findings from there.